Differentiation of trigonometric functions. The basic rules for differentiating trigonometric functions are in the booklet of formulae and tables on page 25, but they are shown only for x. For more complex functions, use the chain rule. Therefore, if you are using the tables, replace x with u and always multiply by du dx. Note, powers of trigonometrical functions such as sine squared x are usually written without parentheses. When differentiating such expressions, always put in the parentheses. Thus, we write sine squared x as sine x to be squared. So basically just add in brackets. So these are the rules on page 25. So if f of x is cos x, then f prime x is minus sine x. If f of x is sine x, then the derivative is cos x. And if f of x is tan x, then the derivative is sec squared x. So the chain rule for trigonometric functions, if f of u is cos u, then using the chain rule, the derivative will be minus sine u multiplied by du dx. So the derivative of whatever is inside the cos angle. If f of u is sine u, then the derivative will be cos u multiplied by du dx. And if f of u is tan u, then the derivative will be sec squared u times du dx. So the chain rule is essentially the outside inside rule. So it's the derivative of the outside function multiplied by the derivative of the inside function. Find the derivatives of the following functions. So cos 3x. So if y is equal to cos 3x, then the derivative, dy dx, will be minus sine 3x multiplied by 3. So we take the derivative of cos. So if our function is cos u, the derivative is minus sine u. So cos 3x becomes minus sine 3x. So cos becomes minus sine, we keep the angle, and then we multiply by du dx. So we multiply the derivative of the angle. So the derivative of 3x is 3. So minus sine 3x multiplied by 3 is minus 3 sine 3x. So again, it's outside multiplied by inside. Tan cubed 5x. So if y is equal to tan cubed 5x, we can rewrite that as tan 5x to the power 3. So dy dx, so we differentiate the outside, so we bring the power down in front, we keep the angle tan 5x, we reduce the power by 1, 3 minus 1 is 2. So that's the outside. Then we multiply that by the derivative of the inside. So inside we have tan of 5x. So if our function is tan u, then our derivative is sec squared u multiplied by du dx. So instead of sec squared u, we'll have sec squared 5x. And then we multiply that by the derivative of the angle. So the derivative of 5x is going to be 5. So this is the power, this is the trig function, this is the angle. And then we just simplify. 3 multiplied by 5 is 15. Then tan 5x squared is tan squared 5x. And we just bring down the sec squared 5x and it's all stuck together. X sine x. So if y is equal to x sine x, they're stuck together, so we're going to use the product rule. So the product rule is u dv dx plus v du dx. So u is x and v is sine x. So we write down u, which is x, with brackets. Then dv dx, the derivative of v, so the derivative of sine x is cos x with brackets. Then we have our plus. Then v, we write down, which is a sine x. And we multiply that by du dx, the derivative of u. So u is x, so the derivative is 1. And then we simplify. So x times cos x is x cos x. And sine x by 1 is sine x, with a plus in between. Part 4. Root cos x. Well, root cos x can be rewritten as cos x to the power of a half. So we differentiate, we bring the power down in front, the half comes down in front, we keep the angle cos x, we reduce the power by 1. A half minus 1 is minus a half, so that's the outside. Then we multiply that by the derivative of the inside. So the derivative of cos x is minus sine x. So that comes from page 25 of our tables. So that's the inside. Okay, so the half I'm going to bring over, and the dot means multiply. And cos x to the power of minus a half is 1 over cos to the power of positive a half. Then the dot means multiply. And minus sine x I'm going to rewrite as minus sine x over 1. Then cos x to the power of positive a half I rewrite as root cos x. And everything else stays the same. Then I'm going to do top by top, bottom by bottom. 1 multiplied by 1 multiplied by minus sine x is minus sine x. And 2 multiplied by root cos x multiplied by 1 is 2 root cos x. If f of x equals x squared over x plus cos x, evaluate f prime of pi over 2. So f of x is x squared over x plus cos x. So we have a fraction. So the top is u, the bottom is v, and we're going to use the quotient rule to differentiate. After we've differentiated, we can sub in pi over 2. So v is going to be x plus cos x, so we write that down with brackets. That's multiplied by du dx. So the derivative of x squared is 2x. Then we bring over the minus. Then we stick on u, which is x squared with brackets. And that's multiplied by dv dx. So the derivative of x plus cos x, well, the derivative of x is 1. The derivative of cos x is minus sine x with brackets. And that's all divided by v squared, which is 1 plus cos x 2v squared. Next, we can sub in pi over 2 in place of every x. So we get x plus cos x becomes pi over 2 plus cos pi over 2. 2x becomes 2 times pi over 2. X squared becomes pi over 2 squared. And 1 minus sine x becomes 1 minus sine pi over 2. And that's divided by x plus cos x to be squared, which is pi over 2 plus cos pi over 2 to be squared. So notice that we did not simplify, we just subbed in x to be pi over 2. So cos pi over 2 is equal to 0. You can get that from your calculator if you don't know it already. So this cos pi over 2 is going to become 0. The 2's here will cancel, leaving us with pi. So we've got pi down here. Pi over 2 to be squared will give us pi squared over 4. Sine pi over 2 will give us 1. Again, you can get that from your calculator. So we've got 1 there. And cos pi over 2, again, is 0. And the rest stays the same. Next, we can start to simplify. So we get rid of the 0. 1 minus 1 is 0. That's where that 0 comes from. And we can cancel out that 0 as well. So we have pi over 2 times pi minus pi squared over 4 times 0, all divided by pi over 2 to be squared. So pi over 2 times pi is going to give us pi squared over 2. Pi squared over 4 times 0 will just cancel out. So we just have pi squared over 2 as our numerator. And then our denominator, pi over 2 to be squared, gives us pi squared over 4. So we square the top and the bottom. So pi squared over 2 divided by pi squared over 4 can be rewritten as pi squared over 2 divided by pi squared over 4. We change divide to multiply, turn our second fraction upside down to give us 4 over pi squared. Then we do top by top, bottom by bottom. So pi squared times 4 is 4 pi squared. 2 times pi squared is 2 pi squared. The pi's will cancel. And 4 divided by 2 is 2.